Today we're going to talk about our final piece, graphing polynomial functions. So we're going to put all our lessons together from add, subtract, multiplying polynomials, dividing polynomials, factoring polynomials, possible zeros, finding x-intercepts, end behaviors. We're talking about end behaviors today. We're going to bring it all together and tie it together. So I'm going to start with end behavior. End behaviors are important because it tells you what's happening at the end of your graph. Where does my arrows go? There are 4 options, but I just want you to, don't try to memorize it, I want you to understand. So think of a line. If I have y equals x, right? We know that's linear. How does my graph look like? It's a line. Well, my end behavior is down, up. What happens if it's a negative slope? End behavior is down the mountain, my slope, so it's up, down. So what we can conclude is that if my exponent, my leading coefficient, and my highest degree is odd, think of a line. Think of down, up, down, and then look at the leading coefficient. Think of slope. So if it's a positive a value, it's going up, so down, up. If it's a negative slope or leading coefficient is up, down. Right? If I give it x squared, we have a happy face. So what are my end behaviors now? It's up, up. And what happens if y equals negative x squared? That's a sad face, and then down, down. Alright, so whenever we have an even highest degree exponent, it's either going to be up, up, or down, down, based on if the a value is positive or negative. But we know about reflections. If it's positive, it's a happy face. If it's negative, it's reflected on the x, so it's going to be a sad face. The reason why I want you to think of lines and parabolas is because that's what we've been focusing on this whole time. Since Algebra 1 and Algebra 2, we do a lot of linear and quadratics. We're not too familiar with higher degree exponents, so instead of memorizing up, up, down, 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 up, down, I want you guys to focus on, if it's a line, I know how a line looks like. It's down, up, down. And if it's a parabola, I know how a parabola looks like. It's either happy face, sad face. So it's either up, up, or down, down. All right, that is going to help us. Everything else we've learned from our other videos, now we combine it all. So let's say we do, we have some function, and then we do p over q. So you find our possible zeros. These are our steps. So step 1, do p over q, find your possible zeros. Step 2, do synthetic division. Synthetic division and get a remainder of 1. So get a remainder of 0, which also means that my remainder is 0, that means that value we tested is our x-intercept. So if I get 0 here, then this guy here is going to be your x-intercept. Once we have that, we also know that this is my x-intercept. Let's say it's like question mark, then x minus the question mark is a factor. And what you just done is you broke this equation up, this polynomial function, you took out a factor, you broke it up into one piece. And then this is what's left over. Alright, if it's quadratic, we can use all our quadratic methods, factoring, guess and check, x method, box method, quadratic formula, so many ways to find x-intercepts. If it's cube, and maybe there's 4 terms, we can try grouping. If grouping doesn't work, then we got to do synthetic again until we break it down into x squared. My goal is to get x squared here. Our goal is to get quadratic here. And then step 3, find all x-intercepts. And then step 4, you're going to graph them. Graph x-intercepts, y-intercepts, and then end behavior. Alright, one little tidbit, I want to talk about multiplicity. So multiplicity just states that if you factor these guys out, so you get x minus 1, x plus 1, Multiplicity just means how many times is your factor repeating. Here it's only repeating once, here it's repeating twice. So what that means is at x at 1 and at -1, my x-intercepts, your multiplicity is 1 here, and your multiplicity is 2. What that means is if it's an odd multiplicity, then it's going to go through the x-intercept. It's going to go through it. If it's even, it's going to bounce off. So here, if we have x-intercept here, it's going to go bounce off. Here, if an x-intercept here, it's going to go through. All right, that's going to help us when we start graphing and connecting the dots. So that concludes our lesson with graphing polynomials. We're going to do 3 problems, your beginner, intermediate, advanced problems. Try your best. We'll get there, I promise. Let's get ready for some videos. Okay, let's do this problem here. I want you to factor completely and find the multiplicity. So factor, find multiplicities, and then find and talk about end behaviors. And try your best. It's a big problem for a beginning problem. But try your best. About a minute for this. Try your best. Go. Alright, let's try this. The first thing is we need to find P over Q. That was your step 1. So factors of 24 divided by factors of your leading coefficient. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. There's a lot. Plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. Divided by plus or minus 1, so we don't really care about that guy. These are my options. I do need to test values. I'm going to test 3. I'm just going to pick one. So you have 1, -5, -2, 24. So when you do this problem, you have 1, drop the 1, multiply, -2, -6, -8, -24. You get 0. That's what we want. So that means this is an x-intercept. That means x minus 3 is a factor. And this is what's left over. Right? It's quadratic, so we can actually just go ahead and factor. So I'm going to do it here. So I'm going to factor x squared minus 2x plus 8x, 4 and 2, minus plus. So my x-intercepts are at 3, 4, -2, but my multiplicity is for each one, each factor it only repeats one time. There's only one exponent to the 1 power. So that means each guy is 1, which means what? That means at 3, 4, -2, your graph is going to go through, sometimes we call it sliding through, those specific x-intercepts. What are my end behaviors? Well, we look at this guy here. All I care is about that guy. I don't care about anything else. It's odd. So what I tell you think of, if it's odd, yeah, think of a line. Down, up, down, but it's a positive, so like think of positive slope. So my graph should be like that. So down, up. So those are my end behaviors. So what you can state is as x approaches -infinity, f of x approaches -infinity. What that means is as we go left, my graph is going to go down. And as x approaches positive infinity, as we go right, where's my graph going? Up, good. So f of x approaches positive infinity. So this means as we go left, we go down. As we go right, we go up. Down, up. Right? Check your answer. It's a big problem. But let's move on to our intermediate problem. All right, our intermediate problem. Let's try this problem here. I want you to graph the whole thing. So I want you to do P over Q's, do synthetic, find the x-intercepts, keep breaking it down if you need it, factor completely, find, graph it, find end behaviors, do all that good stuff, and multiplicity. Go. All right, let's take a look. So possible zeros, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12 plus or minus 24 divided by my a value. So you actually have 2 now. So when you divide all of these guys by 1, it's just going to have the top numerator, but you also have to consider when you divide by 3. So I have all these guys. I'm going to list them all out. I know it's tedious, but we got to list them all out. Plus, we have our fractions. A lot of them are going to double up on the ones we already have, so you don't have to write them down. But we need 1/3. We need 2/3. 3/3 is 1, so we don't need that. We need 4/3. We don't need 6/3, that's 2. We need 8/3. And I think that's about it. 12/3, 4, 24/3, 6. So, yeah, so we just have to add these 8 other ones. Alright, now we use synthetic. Let's test one. I'm just going to try one. Let's try, yeah, we can try any value. So let's try 1. So we try 1, you get 3, 1, negative 38, 24. We start trying it. We realize what happens when you, so 4 here, you get negative 34. We know it's not going to work. Alright, so we got to try a different value. So 1 did not work. So let's try negative 4. You got to keep trying. This is where the tedious part comes in. So 3, 1, negative 38, 24. You get 3, you get negative 12, you get negative 11, you get 44, you get 6, and you get negative 24. So it actually did work. So x equals negative 4 is an x-intercept, which means what? X plus 4 is an x-intercept. This is what's left over. So you have 3x squared minus 11x plus 6. So we can factor this guy. So you have x plus 4. You have 3x x minus 2 minus 3. And then we can get negative 4 is my x-intercept, 2/3 is my x-intercept, 3 is my x-intercept. My multiplicity is 1 because they only have 1 pair of each. They have 1 each, so then at those guys it's going to go through. My end behavior over there, odd, positive a value, so it's down up, it's like a line. Let's graph this guy. You have negative 4, you have positive 3, you have 2/3. Where's my y-intercept? You come all the way here to find my y-intercept, which is 24. I'm just going to estimate it here. Let me see how it's down up. So then we said it's just going to go through my x-intercepts. That's my multiplicity. So we connect everything. You get that. Be careful. Your y-intercept is not your maximum value. It's actually in between these guys here. So it should be somewhere here. Same thing here. It should be in between there. Okay. So that concludes our lesson. We're only doing 2 problems because these problems are long. But remember all the rules, end behaviors, synthetic division, possible roots, factoring, all of those you need, end behaviors, all of that we need to be able to graph and connect it all together. That's our final. So hopefully this video helped you. Please subscribe to my channel. Please turn on notifications and let's get ready for some more videos. Good job.